we're asked to evaluate the given indefinite integrals, the directions may also say determine the antiderivatives. For these two examples, we'll be using the method of U-substitution. When integrating using the method of U-substitution, we let u equal part of the integrand function such that differential u matches the remaining part of the integral, where differential u is equal to the derivative of u with respect to x times dx. So for our first example, we have the integral of the product of 10x to the fourth plus 6 and the 6th power of x to the fifth plus 3x minus 1. Well, first notice how we can factor 2 from 10x to the fourth plus 6. Let's begin by factoring out the 2. This gives us the integral of 2 times the quantity 5x to the fourth plus 3 times the 6th power of the quantity x to the fifth plus 3x minus 1. And now our goal is to determine what u should be such that differential u matches the form of the remaining part of the integral. One giveaway is that we have the quantity x to the fifth plus 3x minus 1 raised to the 6th power, and we have the quantity 5x to the fourth plus 3 raised to the 1st power. We often let u equal the part that's raised to the power, so let's try letting u equal x to the fifth plus 3x minus 1. Notice by letting u equal x to the fifth plus 3x minus 1, if we go back to the integral, this is now u raised to the 6th power. The next step is to determine differential u, where differential u is equal to the derivative of the quantity x to the fifth plus 3x minus 1 with respect to x times dx, which gives us the quantity 5x to the fourth plus 3 times dx. And now looking back at the integral, this is good news because if differential u is equal to the quantity 5x to the fourth plus 3 times dx, we can now substitute du for, again, the quantity 5x to the fourth plus 3 times dx. And we can factor out the 2. So writing the integral in terms of u, we have 2 times the integral of, again, if u is x to the fifth plus 3x minus 1, this is now u to the 6th. And the quantity 5x to the fourth plus 3 dx is just du. Notice how this simplifies the integral dramatically. And now we integrate with respect to u using the power rule of integration, which gives us 2 times u to the power of 6 plus 1, which is 7, divided by 7, plus c. And for the last step, we write this back in terms of x, which is equal to 2/7 times, instead of u to the 7th, again we have the quantity x to the fifth plus 3x minus 1 raised to the 7th plus c. And we often identify the result of an indefinite integral or the antiderivative using big F of x. So let's go ahead and say big F of x is equal to 2/7 times the quantity x to the fifth plus 3x minus 1 raised to the 7th plus c. This is the family of functions whose derivative is equal to the original integrand function. And now let's take a look at the second example, where we have the integral of 6 divided by the quantity 2x plus 7 raised to the fifth. Once again, because we have the quantity 2x plus 7 raised to the fifth, let's try letting u equal 2x plus 7. And I do say try because sometimes we'll try u-substitution and it doesn't work, and then we just try again by letting u equal a different part of the integrand function. But in this case, if u is equal to 2x plus 7, notice now the denominator is just u to the fifth, and we're left with 6 dx. The next step is to determine differential u, which is equal to the derivative of 2x plus 7 with respect to x times dx, which gives us 2 times dx. And here we have a choice. Going back to the integral, here we have 6 dx, and we have du equals 2 dx. So we can either multiply both sides by 3, so the right side is 6 dx, or we can just solve for dx. I'm going to go into solve for dx by dividing both sides by 2. Notice this indicates that 1/2 du is equal to dx. And now looking back at the integral, because 1/2 du equals dx, we can replace dx with 1/2 du in the integral. So now let's write the integral in terms of u. Let's go ahead and factor out the 6. So we have 6 times the integral. If we factor out the 6, the numerator is now 1, and the denominator is now going to be u to the fifth. And then dx is equal to 1/2 du. Let's factor out the 1/2, and then we have du. And notice now this simplifies the integral. This is equal to 3 times the integral of, Let's write 1 divided by u to the 5th as u to the power of negative 5. And now we can integrate using the power rule of integration, which gives us 3 times u to the power of negative 5 plus 1, which is negative 4, divided by negative 4 plus c. And again, the last step here is to write this back in terms of x, which gives us negative 3/4 times u to the power of negative 4, which is the quantity 2x plus 7 raised to the power of negative 4 plus c. Let's also show how to write this using a positive exponent. This is equal to negative 3 divided by the product of 4 and the 4th power of the quantity 2x plus 7 plus c. So again, we can say that big F of x is equal to, again, negative 3 divided by the product of 4 and the 4th power of the quantity 2x plus 7 plus c. I hope you found this helpful.